It's really great to be here to share this movie with you, a great film. I mean, I haven't seen it myself, so I'm going to hang around, check it out with you. I've seen the trailer, did some reading, all that kind of stuff. But just a tiny bit more on me. So I'm an associate professor of energy geoscience at Eastern. And with that, I'm also, unfortunately, the department chair. And everyone's going berserk at this time of year. But to cut to the chase, when I was first invited to be here with you, I thought, how could I add to your experience of this film? To add some enrichment to this. And so, I watched the trailer, did the reading, as I said. And with that, I started to think like, wow, what really worked was our hero in the story. Again, I've only seen the trailer, but not to spoil it for you, we do have a happy ending. But yeah, we have a young man who's good with his hands and he's good with his head. And he did something really great for his community. He harnessed the wind and brought to his community and for his family something that they didn't have before. And I thought about what was that, and basically you could reduce it down to one word, and it's energy. And if you think about it, we're here in part because we're interested in learning about people in different parts of the world, their different life that they have from us. And so the big thing about this behind the scenes is really this idea of energy. Now, it's almost inconceivable for us to think of being in a place, living in a place where that word doesn't really exist. And for where we are, we take energy so for granted. I mean, it's to us, it's like breathing. And you don't even think about breathing until you stop. And on this idea of taking so much of this energy for granted, I mean, we've all at some point, you've gone camping, right? Camping's fun. You goof around and around the campfire, and you've got your sleeping bag and all that kind of thing. But camping sometimes can go like really bad where it's not fun. And we've all been through that. It's called a blackout. When we lose that electricity, what was it? Hurricane Ian was the one a year or 2 or 3 back or something like that. And we didn't have power. And okay, so you bear with it for a couple hours, and in that case, some people had to bear with it for a couple of days. That's not fun, because energy for us, and when I say us, I mean U.S. We are so tied to energy, it's mind-boggling. So what I thought I could do to help us understand and better appreciate the significance of this young man's achievement for his family, he made them proud, and for his community, he's their hero, bringing energy into their lives because they don't have it. To help us really appreciate the significance of that, I thought we'd help to frame just what a big role it plays in our lives. So why don't we actually jump into this thing? So as I do in my classroom with my students, I'm constantly bombarding them with questions. If they ask me a question, they get a question back. What am I looking at? I'll give you a hint. Historical event. Feel free to shout it out. Okay, so I got that in dodecaphonic.
Gulf.
Yeah, this is the
BP horizon.
Yeah, the BP oil spill that happened in April of 2010, right? And that thing dragged on through April, May, June, July. You could go online, live stream it, the whole deal. And we're down 4,900 feet. This is May the 15th in 2010. So 24 hours a day, 7 days a week for four plus months. It's gushing out oil. That went up to the surface, right? Killed birds, messed up the beaches. The whole shrimping industry went down the tube. The restaurants didn't help the restaurants. That ripple effect, the tourists weren't coming around. The whole deal is a total mess. But that was the biggest spill that's out there, 5 million barrels. To frame that comes out to about 200 million gallons of crude oil. I mean, think of going down to Wally, pick up a gallon of milk, bring it home, drop it on the floor, look at the mess 1 gallon will do. So think of 200 million of those. Now, I probably shouldn't have held this. So 200 million gallons. Let me frame it another way. 200 million gallons for the United States, we will literally use and burn up that much oil 6 hours.
Oh my God.
To keep this country running, think of our need for energy in the U.S. as like a pizza. And there's one slice called oil. To run this country, and this is ignoring the coal, the gas, the nukes, the geothermal, the wind, the solar, just a slice for oil. We need 4 BP oil spills every single day for this country alone. It's mind-boggling. We use so much energy, we can actually see it from outer space. We can actually see us using it. So now, the basic energy that we use, whether it's in the US or globally speaking, is what science nerds like me would refer to as primary energy. And that in some sense is what when we talk about primary energy, it's what happens to what you get when you break chemical bonds within some kind of thing like crude oil or coal, whatever. But 80% of it right now is fossil fuels. Pretty evil. So we can actually see us, U.S. consuming energy. Here we are, just chewing it up. This is a NASA composite photo. If I remember correctly, it's about 6,000 images stitched together. They cherry-picked it. They only took the night images that were free of clouds. And of course, half the planet at any one moment should be lit by the sun, right? So this is total Earth. There we are, our friends in Europe. Pop quiz, who's this? Yeah, we got Japan. What's the diamond? Yeah, good. Midterm's coming. Why is it dark?
Mongolia. Oh, the Himalayas.
Yeah, the Himalayas, the Tibetan Plateau, and somewhere in there, of course, is Everest, right? But in accordance to fit with our story, front and center, I've got a huge landmass, the African continent, and we know there are a lot of people there. But it's dark as night. Remarkable. Obviously, in some places, we have these geographic constraints. Over here, as said, we got the Tibetan Plateau, the infamous outback. What do we got, troops?
Amazon.
Amazon, yeah, you bet. But, you know, we've got people there, and Africa is, in fact, rich with natural resources. But for a variety of reasons, they have not tapped into them, or for some of the resources they have tapped into, it's not gone their way. Okay, which is a whole side topic. But nonetheless, we can see that use of energy for us, Europe, etc. Now, how are we keeping the lights on? The unholy trinity, oil, coal, gas. Those are the big ones for fossil fuels globally. And there are others out there that are kind of nasty too. These things called tar sands, there's oil shales, there's all kinds of stuff. We don't see and hear that stuff much. There's a lot of it. It's mostly market driven. But that's the fossil fuel mix that we're all tapping into every single day. You drive a car, you're a part of this. You heat your home, you're a part of this. Virtually everything you do, I do, we're a part of this. So let's jump and figure out what's up with the other 20%, if we can advance there. Yeah, well, the other 20%, I guess, is something we call the green stuff, right? The renewables. You know, we got the solar kind of thing. There's my alma mater there, yeah. And fitting with our story, wind, you know, wind's big. But when you get into the weeds about what is the green stuff specifically, so let's jump to our next one here. Yeah, here we go. Data out of 2021, April 22, from an agency you probably never heard of called the Energy Information Administration, another place where your tax dollars end up. And what we got is, here's that piece of pie for the United States. And this energy, all energy to run our vehicles, the trains, the planes, the boats, the whole deal, plus all of our structures, right? We've got to heat buildings, cool buildings, that kind of thing. We also have to think of industry. Fossil fuels are huge in steel, making concrete, all that kind of thing. But out of this energy pie, a full third of it goes to oil. And if this was a snapshot on any one given day, I've got to put in here 4 BP oil spills. And I haven't even started talking about another third is entirely gas. Using the new F word, not that F word. fracking. And then we have this other third, which is split into thirds. There's the dark and evil coal, which is, hallelujah, it's going away. Nuclear, some people feel that nuclear actually belongs in the green chunk. But on the green side, 12% is about 1/8 of the pizza. Gotta be careful. If I call that 25%, wind is about 1/4 of the 1/8, which means in the big picture, wind is only about 3%. And if I think about hydro, I call that 20%, that's a fifth of the 1/8, which is going to be about 2.5%. Wind is still pretty small. Solar, oh man, it's down to like 1%. It's incredible. But you know, oddly, I know I'm going to kill myself. A healthy chunk of this is called biomass. Now what that is they're taking some kind of organic stuff like waste wood, you know, like Wally delivers 10,000 cases of diapers and it's on a pallet. You know, what are you going to do with the pallet? That stuff can end up being incinerated. Hopefully when they do that, they're going to, you know, create some electricity from it. That is being done more and more. But the reason why that's being called renewable is because you think about it, the wood that went into the pallet was once a tree. The tree to grow had to take in carbon dioxide to make more tree. And then they chop it down, make the pallet. But then when you burn the pallet, that carbon dioxide the tree took in is released back out for the next tree. And we get a loop going. And therefore, because of that cycle, we call it a renewable energy source. You know? But we're putting a lot of trash in there, right? Because right at the junction of, 84 and 91, 91 heading up to Springfield, remember that big green hill on the right, the landfill? Nowadays, on the back side of that, we've got solar panels. But landfills in the traditional sense are gone. We essentially incinerate everything, pretty much, you know? Here's another place where your tax dollars have gone. This is census.gov pop clock. I know, we need a guardrail back here. So we got the U.S. population as of, well, moments ago, at 334 million. The global side, according to Uncle Sam, is a whiff below 8 billion. UN declared back in November it crossed 8 billion. It really depends on who's doing the counting and how they're doing the counting. As an example, here's one government website, and that's our population, but yet on the same page, do the numbers match? No. Not quite. And yet on the same page, do the numbers match? Yeah, well, you have to pay more taxes if you want to get it right. So I guess the deal is, this is kind of crazy. We are the third most populous nation on the earth. It is predicted right now, what I just saw actually it was in this month of National Geographic, that China and India are going to flip by the end of the year. And it will be the first time in centuries that China has not been the largest, most populous nation in the world. And so we are third. Now, our number fits into that number. And if you do the math, what you find out is that for us here in the United States, our population is only 4.5% of the total global population, you know, 4.5%. Now, we have other nations, of course, down the list, but there's a key point to be made for that. We're only about 5% of the global population. Some fairly new numbers, again, from EIA. I'm not going to get into the weeds on this. What I want to show you is literally the bottom line, which is if I round that off to a friendly number, I'm going to call it 100. And this is what we call quadrillions of BTUs. There's a lot of ways of expressing energy consumption by various means. In the case of, we just call it BTUs. We use roughly 100 of these QBTUs every year. Globally, the number is 600. Now, our number, the 100, fits in with that number. So what that means, we're about not even 5% of the world's population, but yet we are using 1/6 of all the world's power. One nation, that's it. It is unbelievable. We have the biggest GDP on the planet. The numbers as of today from the World Bank is that our GDP every year comes out to be $23.3 trillion. For China, it's $17.7 trillion. Way down the list, you've got the UK at $3 trillion. Wow. Amazing that one country that has such a tiny fraction of the overall population is using so much energy. I teach a class, I throw this out there, the class is called Sustainable Energy, and I tell the students, is that sustainable? I mean, come on. So I actually clipped this out of this month's Geographic. Here it comes. So in the global picture, if a nation is in red, what's happening there is that birth rates for women who are of age to have to bear children have their birth rate, average birth rate in that nation is slipped below 2.1 children per woman of childbearing age. And that is the replacement rate. In other words, they replace the couple and count other factors, accidents, disease, all that kind of thing. If it's in green, we're back at to nations where for women of childbearing age, fertility rate is 4 children or higher. And then blue is, of course, the middle. And our hero in the film comes from this country, Malawi, the skinny little thing right here, which, to give you some scale, Malawi is just a whiff bigger than Cuba, spatially speaking. And the reason why I show this is that because all these nations are consuming energy. And of course, we are the piggy ones. But the thing is, in the past decade or two, China has been going crazy with its development, just skyrocketing. Their typical growth every year for their economy is like 8 or 9%. That's bonkers. And right now, their population is slowing down a little bit. And so while they were going through this boom period here with their economy, what they were really doing, I mean, despite what you and I may think on the political side, disagreeing with how they do their government and how we do our government, for what they did in the past couple of decades, they lifted almost half of their population, 750 million people, out of poverty to something that resembles what you and I would call, well, middle class. But that comes at a price. They've been gobbling up oil like you can't imagine. And they have got mountains of coal that they've been using. There was a point for them about 5 years ago, maybe 10 at most. They were opening up a new coal-burning power plant every single week. Unbelievable. And they're going nuke crazy too. But the thing is, that's a good thing to lift people out of poverty. I mean, quite honestly, whether put aside the politics, just on the concept of social justice, that everybody should live a rich and full life and to their full potential, we're going to see the same thing happening here. Throughout continental Africa, we have a huge population that's kind of in the dark. And they're sitting on all these resources. And they are kind of where China was 20 years ago, 30 years ago. I mean, I remember traveling in China in the earliest 90s, the earliest 2000s, and honestly, it was like opening up a 1920s National Geographic. It's not that way anymore. They've got a pretty impressive highway system that rivals ours. Let's go for our next slide. So, since the middle of the last century, 1950, there was that 60s population boom that was out there that we were all hearing about. And that scared China into putting in the one-child policy, and it kind of slowed down the curves a little bit, And that's contributed to some interesting issues for China, and that's why India is going to surpass them. But going into the second half of the century, by 2050, populations will pick up again, and in particular, the nations that jump the most in general are those in Africa. The United States, we're going to pick up about 10%. Nigeria is going to pick up 60%. So we expect Africa to be picking up population increases, and just to get to 2050, jumps in population of about 50 to 60%. Now, I've got a quick experiment I want you folks to do. Okay? That is going to require some energy if we're going to try to get those people, handle that population without really doing too much to their standard of living. But right now, if you got a phone, whip it out real quick, because I want to, I don't want to blabber too much here. Yeah, you got a phone or something. So real quick, look up real fast. Real Artways, what's the next movie coming? Because I want to sit down and watch it. Anybody got it?
A hidden life of trees.
Oh, slick. That's good. So you just did it on your phone, right? You looked it up. Terrific. They can do the very same thing right there, right now. They can see right now when that next film is going to play. If they dig around some more, they can probably come up with how much you paid for that bucket of popcorn. What's the difference? They can't get here. But yet they see every single thing about our lives. How we dress, how we drive, how we entertain ourselves, the foods we eat, you name it, they miss nothing. You really think they don't want to be a part of this? I mean, they're going to be mindful of their traditions and customs and all that kind of stuff, but they want to better their lives too. That will require energy. Where are we going to get it from? If you've got one collection of people, 5% of the population using, God, a full sixth of all the energy, if we try to lift up their lives to where we are, we're going to need another 4 Earths. And so what's going to happen? Well, part of that journey to try to lift up everybody's standard of living is probably going to involve fossil fuels. We're going to be burning fossil fuels of all types, from the oil, the gas, coal, and be making that thing, the greenhouse gases. And that's the evil one. There are a couple others out there too, but that's the biggie we got to worry about. Let's jump ahead one. So yeah, there we go. So the impacts, here's Beijing, circa the Olympics back in 2008. The last time I was there was like 2003 or so. When I was there, actually, in the earliest 90s, it was, like I said, National Geographic, bicycles everywhere. When I came back a decade later for professional reasons, they discovered something that we've had for a long time. It was called the traffic jam. I mean, cars everywhere. It was so bad that they actually had considered, prior to the Olympics, of moving the capital because they were worried about how the smog would affect the world-class athletes, you know? So all that greenhouse gas stuff is going to, affect this thing that's 100% natural. We need the greenhouse effect. If we don't have it, sun shines on Earth, warms up Earth, Earth gives off some of that heat. It does not go straight out to space. The atmosphere grabs it and re-radiates it back in. And that's like, for you and me at nighttime, that's why we're wearing blankets on the bed, right? The blankets don't heat. They don't give off heat. They're just holding in your heat. So what's up with carbon dioxide and all these greenhouse gases? It's kind of like as we add greenhouse gases to the atmosphere, what functionally happens is it's like you're zonked out at night, and without anybody telling you, they put more blankets on you. At some point, oh boy, you're going to start to overheat. And so the way Mother Nature responds, as we put more and more CO2 into the atmosphere, it's like adding more and more blankets to the bed. Mother Nature will adjust the thermostat up to what she'll call the new number. And she doesn't really care if that new number for the global average temperature fits with particular species. Because along the way, there have been plenty of extinctions. Because I know when you came from the parking lot to here, you didn't see a T-Rex. All right? So the problem is we don't want to have a climate change that happens so quickly it takes us out like the dinosaurs. Because that's what happened to them. There was functionally a climate change so fast they could not adapt. And we've known this whole thing for the climate change naysayers. A dude by the name of John Tyndall, January of 1861, before the Civil War breaks out in the United States, published a paper in the Philosophical Transactions of the Royal Society of London, and through 40-something painful pages, you get down to this diagram. And what he was doing was he was taking different types of gas and exposing it to different types of light. And when he got to one experiment, he discovered that, like, whoa, I've got this glass box full of carbon dioxide, and when I shine infrared light on it, it soaks it all up. And he knew immediately that, whoa, if we keep burning coal, but back in his days, there was no oil. There was no gas. The very first well that was drilled for oil in this country was 1859, the Drake Well, Pennsylvania. He knew immediately that if the British Empire continued to burn coal, burn it, it was going to get into the atmosphere, warm the planet, and if you give it enough time, catastrophically make changes that you might not be able to turn back from. Oh my gosh, that's 160 plus years ago. The whole story was done then. Let's jump ahead. What happens? The world warms up. Mountains with snow caps, glaciers, gone. Next slide. That will affect sea level. I mean, that water's got to go somewhere. It's going to raise the bathtubs. So what it kind of boils down to, what we're doing to the planet, how we are impacting the planet, we can sort of reduce it to 3 factors. One is if you've got lots of people in one place, let's pick a country. Hey, how about the US? Who are really rich, affluent. If you're affluent, you can get your hands on the technology to extract those resources. I mean, for years, we left oil in the ground, even though we knew it was there, because we didn't have the technology called fracking. Now we can pull the last drop out of the ground. We're doing it. We're out pumping the Saudis and the Russians combined right now. Difference? Saudis are still standing on an ocean of oil. They can pump at will. Us, pumping out twice as much as them, we're going for the last drops, gang. And there's only so much down there. But if you're wealthy, as we are, I mean, we're crazy rich. Crazy rich. I mean, you may not envision yourself as a billionaire or a millionaire. Certainly thousandaires, I hope. And certainly some centauries, I don't know. But if you've got $5 right now to buy something, you're just using more money than for a lot of people across the world will have for the entire day. So with big populations who are rich in technology, they're going to have a lot of impact. So here we are again, right? So think about this, okay? We want to raise everybody's standard of living. And for our hero tonight, who harnesses, the wind, he's bringing energy to his family.
Is it anything weird?
You still with me? So the point would come down to this. There we are, us with the energy. Can we keep consuming it the way we've been doing it? Will there be enough to go around for other people? By that little mathy equation I just showed you about the population and the affluence and the technology, well, when we use our affluence to get that technology so we can get those resources to get the energy, we are climatically pounding on this planet. Because functionally, when we say things about climate change and global warming, who's doing it? Who's causing it? It's U.S. It's not those folks. They want to raise their standard of living, and we're trying to get them to do it without the fossil fuels and to try to help them on that process. But, anybody who's lit up here, we're the ones to blame for climate change if we're going to be really honest about it. And so functionally, I'll say this. Well, are we going to keep up our habits of using energy the way we do? Are we going to keep using these fossil fuels the way we've been using these fossil fuels? Or are we going to get smart and on a much, much huger scale than the young man in this movie, will we harness the wind? Can I answer any questions?
Did you go do this report at Congress?
There have been a lot of people in front of Congress. I mean, some folks that, they really know this game inside and out. There's pushback in Congress, as you have heard. There's Jim Inhofe, who is, I think, the senator from Oklahoma. He has strong oil and gas ties. In the world of trying to look at both sides of the coin, he is there to represent his constituents, which would be people and the companies that hire people. So I guess in a way, he's doing what his job is, right? But I do know from colleagues of mine up at UMass Amherst that some of these people in Congress have intentionally harassed these scientists for doing nothing less than just laying out the facts and not trying to push any kind of policy change, just laying out the facts and let the policy people do their thing, So, any other thoughts, comments? Yes, sir.
Did you hear about the opposition to Biden's agenda for wind and the Defense Department?
With the Defense Department?
Defense Department.
No, I have not.
There was an article in the New York Times about opposition to wind off the coast of the Atlantic Ocean due to bases and impact on the military.
Well, no. Specifically, I've not heard that point, but let me throw this out there. In the world that money talks, which is our world, Dominion, which is one of the big oil companies, coal companies that's out there in Virginia and other West Virginia and so forth, they're getting out of the coal game. And they're trying to move their operations into wind power offshore of Virginia on what we call the continental shelf, which is the shallower water. It's like, up to say 300, 400 feet deep or so. So I guess in some respects we could say, well, I guess if Dominion could put some pressure on the military, because it's hard for little people to do it, if I may call ourselves that. Sometimes money talks. They want to get out of that business and they want to go with green energy. And so maybe that might get the Pentagon to sort of rethink things. Yeah.
Methane. What can you say about methane?
Well, I guess there are a couple things you could throw out there. One is that if you look at the bigger picture of the fossil fuels, the evil thing is coal. Because in trying to get coal, you've heard of these things called mountaintop removal. They scrape off the whole upper surface and go for the seam, because they know there's a certain human expense and real dollar expense actually doing the traditional mine underground. So gas is way cleaner. You're not getting into that mountaintop removal thing. You're punching a hole in the ground, that kind of stuff. Yep. On the other hand, there's also no residuals. When you burn coal, you've got the ash. On the other hand, you're creating CO2.
I'm not talking about it as a fuel.
Okay.
I'm talking about it as going up in the atmosphere out of the tundra and out of the...
Yeah, so that's another serious issue, because we've got these things out there called feedback loops. And feedback loops are a situation where you burn fossil fuels, you create carbon dioxide that warms up the planet. So the planet warms up, and what that does, it starts to thaw out, say, polar ice and maybe things called permafrost, which these days is not so perma. And so that stuff starts to rot, and that stuff gets to be released, and that particular greenhouse gas is 20 times worse in holding heat than CO2 itself. And so what happens is these feedback loops, once they start, you don't need the carbon anymore, the CO2, to keep the thing rolling. They'll just keep rolling it themselves. And they can trigger other positive feedback loops, and methane spinning off from rotting biomass is pretty bad. Yes. I hope that answered it. Was I close?
Yes.
Can I get partial credit? Yes.
Speaking of biomass and burning biomass, I'm not entirely convinced that that's a renewable source. I see that you harvest the trees to make pallets or whatever, right? And then you're kind of reusing it, repurposing it. But that gets more CO2 plus particulate.
Yeah, bingo. Yeah, you're going to have this stuff called PM10, particulate matter 10 micron. In other words, what we're talking about here, when I was saying about, say, burning wood chips, right? And you're releasing that carbon dioxide back for the next plant. Well, odds are that combustion process is not clean. It's going to have a lot of side junk coming off of it, okay? One thing you can say about methane gas when they're burning that stuff, if they do it right, that combustion should end up being CO2 and water, okay? But when you talk about the biomass kind of thing, you are going to have these residuals, solids that you have to deal with, but that gives you a smaller landfill. But you still have these particulates going into the air, which affects older citizens and the cute little people, because they're running around, they're very active, they breathe deep, and they take all that stuff in. So, yeah, so the biomass, I don't entirely agree. So right behind you, let me...
seems that we've developed nuclear power to the point where it's pretty safe. What's the possibility of that kind of a shift?
Yeah, on nuclear, two people that are really kind of pushing for a new concept, would be someone by the name, I don't know if you've heard of him, Bill Gates. And this other dude that kind of hangs out with him once in a while, Warren Buffett. And so what they're thinking about, let me try to do a quick encapsulation, say, for nuclear power in the United States. Up until about 4 or 5 years ago, we had about 100 nuclear reactors that were pretty much up and running. Now, that's not 100 nuclear power plants, it's 100 reactors. Now, we've got Millstone down on the shore, and it has 3 reactors, but it's one plant, okay? So over the past couple of years, they've used more duct tape, used more chewing gum to keep them rolling, because they're very expensive to build. A new one opened about 2 weeks ago, the Vogel plant in Georgia. It already had 2 nuclear reactors. They wanted to get in 2 more. They were originally budgeting $14 billion to add those 2 reactors. It is so over budget. They haven't got the 4th one going, but they got the 3rd one going. The current bill is around $22 billion, underwritten by 50% by tax dollars, okay, which they're supposed to pay back. The trend in the United States is that we've been slowly phasing out our nuclear power plants. Why are they crazy expensive? Well, you know, we all had our pants scared off of us with 3 Mile Island. And then came the big boom boom, thank you, Chernobyl. And then not too long ago, a little more than a decade, we had Fukushima, which scared the Germans so much they said, we're going to phase out of nukes. So everyone's scared of it, and there's another problem. Functionally, if the operators know what they're doing, nuclear should run just like Millstone. Not even on your radar screen. But hey, we do have plane crashes once in a while, right? And that makes the headlines. No one worries about screwing up the frosting, the wings of the plane. When the plane crashes, that makes the headlines. That's what scares people. So what's contributing to the cost? There's a lot of fear, a lot of protests, delays, overruns in costs, partly because every single nuclear power plant in this country is a custom-made job. They're not Henry Ford's Model T. Every single one of them is basically a custom job. So what's Buffett after with Bill Gates? They're thinking about mini nuclear plants. Things that are cookie cutter, they're all exactly the same. They would only be like shipping container size. That small. That's not new technology. They were doing that in the 1950s in Antarctica. But for whatever reason, they got rid of those things down there. But it's been done. It's been done. So maybe the new revolution for nuclear power would be these mini units, possibly in every other neighborhood. But what's the other unspoken issue? If it doesn't blow up, what are you going to do with the high-level radioactive waste? We have not answered that question. And in the global picture, right now, nuclear power is about 20% of all of our electrical energy. It's been that way for decades. That's the projection for the next 30 to 40 years as we phase out the fossil fuels and we go with the renewables. Right now, France, 75% of their electricity is nuclear. It's been that way for decades. Not to mention, down the road, we've got the base at Groton. We've got mobile nuclear going in and out of the Thames, you know. We haven't figured out a plan to deal with their waste just yet either. You know, I mean, what's the Navy doing?